An ancient bronze gear could rewrite the entire history of human technology. This video presents 20 artifacts that stand as silent witnesses to knowledge far ahead of their era, challenging everything we think we know about our past. You will gain a completely new perspective on the timeline of human innovation. How did a complex astronomical computer exist 2,000 years ago? And why does a medieval sword contain metal impossible for its time? What does it truly mean when an object is found in the wrong place at the wrong time for history as we know it? Among the broken pottery and marble statues of an ancient shipwreck, a lump of corroded bronze seemed unremarkable at first. Yet when it was carefully examined, researchers found it was the single most technologically complex object to survive from the ancient world. We call it the Antikythera Mechanism. This device, dating from the 2nd century before the Common Era, is a breathtakingly intricate assembly of at least 30 interlocking bronze gears, housed in a wooden case no larger than a shoebox. It was, in essence, a hand-powered mechanical computer. By turning a crank on its side, an operator could make the gears whirl into motion, calculating the future positions of the Sun, the Moon, and the 5 known planets. It could predict solar and lunar eclipses with stunning accuracy, and it even tracked the 4-year cycle of the Olympic Games. The knowledge required to design such a machine represents a profound understanding of astronomy, mathematics, and precision engineering that historians believed was impossible for its time. This was not merely a calendar or a simple clock. It was a physical model of the cosmos, a miniature universe driven by the turn of a handle. The most haunting question is not how it was made, but why this level of genius appears to stand alone. The mechanism's sophistication suggests it could not have been a one-off miracle. It hints at a lost tradition of Greek technological science, a school of thought and craftsmanship that has otherwise completely vanished from the historical record. This single artifact forces us to reconsider an entire era, proving that the spark of advanced mechanical genius flickered brightly long before it was thought to have been lit. From the intricate gears of a cosmic calculator, we now turn to a far simpler object, one whose potential is hidden in plain sight. In the ruins of an ancient Mesopotamian village, archaeologists uncovered a small, sealed clay jar. It seemed utterly ordinary, a common household item from the Parthian period, around 2,000 years ago. But inside this jar was a carefully arranged secret, a copper cylinder housing an iron rod, all sealed at the top with an asphalt plug. To a modern eye, the assembly is strikingly familiar. It looks like a battery. If this jar were filled with an acidic liquid, something as simple as vinegar or wine, a chemical reaction would occur. The acid would act as an electrolyte, allowing electrons to flow between the different metals and creating a small but measurable electric current. The so-called Baghdad Battery could have generated about 1 volt of electricity, a tiny spark of power in an ancient world we assume was devoid of such knowledge. The true purpose of these jars remains one of history's most tantalizing debates. Some scholars propose a practical use, suggesting this current could have been used for electroplating, to deposit a thin layer of gold or silver onto other objects. Others imagine a more ceremonial role, where the faint electrical tingle might have been part of a religious experience, a mysterious sensation attributed to the divine. The most compelling idea is not that this was a widespread technology, but that it represents a fleeting spark of experimentation, a path of inquiry that was discovered, used for a time, and then forgotten for centuries. This unassuming clay vessel challenges the very timeline of invention, forcing us to ask if the fundamental principles of electricity were understood long before the famous experiments of the 18th century. It is a quiet but persistent whisper from the past, suggesting that the glow of discovery can appear in the most unexpected places, a theme that continues with our next artifact, an object that seemed to hold its own mysterious light. Deep within the crypt of an Egyptian temple, stone walls tell a story that looks eerily familiar. In the Hathor temple at Dendera, intricate carvings show massive, elongated objects, each holding a snake that stretches from a lotus flower to a wire, all contained within what appears to be a transparent bulb supported by a pillar. To a modern observer, the image is unmistakable, a giant ancient light bulb. Mainstream archaeology offers a different interpretation, explaining that this is a profound religious symbol. The scene is thought to represent the Egyptian creation myth, with the snake as a symbol of the god Hapi, and the lotus flower representing birth and cosmic emergence. It is a spiritual narrative carved in stone, yet the technological interpretation is compelling. Could these carvings be a literal depiction of illumination, of a technology that used devices like the Baghdad Battery to generate light in the deep, windowless chambers of the temple? The theory suggests the snake represents a glowing filament, the bulb a protective glass enclosure, and the pillar and wire a complete electrical apparatus. This idea remains firmly on the fringe of accepted history, a classic example of how our modern perspective can reshape our view of the past. The true power of the Dendera reliefs lies not in proving ancient Egyptians had electric lights, but in demonstrating how easily the line between symbolic art and technical diagram can blur over millennia. It forces us to confront a fundamental question: how do we distinguish a spiritual metaphor from a lost instruction manual? This puzzle of interpretation gives way to a far more concrete mystery, an artifact whose physical reality is as confounding as any symbolic carving. High in the Andes Mountains, the fortress of Sacsayhuamán presents a puzzle built from stone. Its walls are composed of colossal limestone blocks, some weighing more than 100 tons, each one cut into a unique polygonal shape with dozens of complex angles and beveled edges. These gigantic stones fit together so perfectly that the seams between them are virtually invisible, defying the passage of centuries. It is often said that you cannot slide a single piece of paper, let alone a razor blade, into the cracks. This was not a simple stacking of bricks, it was a three-dimensional stone jigsaw puzzle of immense scale and complexity, assembled entirely without mortar. The result is a structure of breathtaking stability, one that has withstood countless powerful earthquakes that have leveled later Spanish colonial buildings in the region. How could the Inca, working with stone and bronze tools, have achieved such a feat? The standard explanation suggests they used harder stones to pound the blocks into shape, a process of patient abrasion that would have been unimaginably slow and labor-intensive for stones of this size. Yet the precision of the cuts goes far beyond simple pounding. The joints are so exact that they suggest a method of cutting and shaping that we do not fully understand, a technique that allowed the builders to transfer the complex pattern from one stone to its neighbor with micrometer perfection. The logistics are equally baffling. How were these 100-ton behemoths, quarried from sites miles away, transported up and down steep mountain valleys without the wheel or draft animals, and then lifted into place with such perfect alignment? The walls of Sacsayhuamán stand as a silent testament to a lost school of engineering, a profound understanding of geometry, geology, and seismic forces that seems to belong to a much later age. This mastery over stone invites us to look at another American marvel, one that demonstrates a different kind of knowledge entirely, written not in massive blocks but in delicate, shimmering code. These scattered stone blocks in the Bolivian highlands seem to defy the very idea of a primitive past. At Puma, Punku, You are not looking at rough-hewn monuments, but at what appears to be a sophisticated industrial project, shattered and abandoned. The building blocks of this site are made from andesite, a stone as hard as granite, yet they are cut with a finesse that feels utterly anachronistic. Massive H-shaped blocks locked together with an almost modular design, each one featuring perfectly straight edges, flawless 90-degree angles, and a uniform thickness that is maintained across entire slabs. The surfaces are not just smooth, they are flat, polished to a degree that suggests a process far beyond pounding stones together. Most telling are the intricate details, the precise geometric channels carved into the stone, and the perfect cylindrical drill holes that pierce through the hard rock. These are not the rough, conical holes made by a handheld drill. They are clean, consistent, and deep, as if made by a machine applying immense, steady pressure. The simplest analogy is to look at a modern countertop fabricated in a workshop, where diamond-tipped saws and computer-guided routers create perfect seams. The stonework of Puma Punku bears that same signature of precision engineering. Conventional explanations suggest that ancient artisans used stone tools, sand abrasives, and immense patience to achieve these results. Yet the sheer scale and perfection of the work, combined with the incredible hardness of the materials, make such a process almost unimaginable within any practical time frame. This was not just construction, it was mass production. The identical, interlocking pieces hint at a standardized system, a kind of ancient prefabrication that required a deep understanding of geometry and a master plan. The site forces a difficult question. Could a society with only simple tools have possessed a conceptual knowledge of advanced manufacturing, of precision and uniformity, that we would not see again for thousands of years? This mystery of a potentially lost, advanced civilization in the Americas finds a strange and distant echo in another part of the world, with an artifact that is equally small and equally baffling. The flawless stonework of Puma Punku speaks of a forgotten industrial precision, but another mystery from the Americas trades colossal scale for uncanny artistry. Life-sized human skulls carved from a single block of flawless quartz crystal have captivated imaginations for over a century. The most famous of these, the Mitchell-Hedges skull, is a masterpiece of optical clarity. Its jaw is a separate piece, yet it fits perfectly with the cranium, and the interior is carved with baffling prisms and light pipes that make the entire object seem to glow from within. If this object were genuinely ancient, created by a pre-Columbian civilization like the Maya or Aztec, its creation would border on the miraculous. Quartz crystal is one of the hardest materials on Earth, only slightly softer than diamond. To carve, shape, and polish it to such a perfect, smooth finish without introducing a single scratch or tool mark would require technology far beyond simple stone and wood. It would demand diamond-tipped tools, precise rotary instruments, and an advanced understanding of optics to plan the internal light channels. For a time, these skulls were held up as the ultimate proof of a lost advanced civilization. Yet the story took a turn. Scientific analysis has since shown that the crystal used in many of the most famous skulls bears the microscopic marks of modern lapidary wheels and polishing compounds. Most are now widely considered to be clever hoaxes, crafted in the 19th or 20th century to feed a growing fascination with the occult and ancient mysteries. So why do they still hold such power? The crystal skulls represent something deeper than a scientific debate. They embody our profound desire to find tangible proof of the impossible. They are a mirror reflecting our own longing for a past that is more mysterious, more advanced, and more magical than the history books allow. The debate they inspire, a constant tug of war between marvel and hoax, prepares us to examine an artifact whose authenticity is unquestioned and whose existence is perhaps even more incredible. While the crystal skulls tempt us with a mystery of modern fabrication, the Iron Pillar of Delhi presents an opposite marvel, one whose authenticity is beyond any doubt. This 23-foot-tall column of iron has stood in the open air for more than 16 centuries, exposed to monsoon rains and scorching sun, yet it shows almost no signs of rust. It is a monument not of stone but of metal, and its endurance defies the natural behavior of iron. Modern wrought iron, left unprotected, would have crumbled to a pile of reddish flakes long ago. So what is the secret of this ancient sentinel? The answer lies in its unique chemical composition. The pillar is forged from an exceptionally pure form of wrought iron, but its true protection comes from an accidental masterstroke of ancient metallurgy. The iron contains a high amount of phosphorus and a very low amount of sulfur and manganese. This specific recipe, when exposed to the atmosphere over time, encouraged the formation of a thin, invisible, and remarkably stable protective layer called mesawite. This passive film acts as a shield, preventing oxygen and moisture from reaching the underlying metal and starting the corrosive process we know as rust. For centuries, this protective layer has healed itself, a testament to a perfect, if perhaps unintentional, balance of materials. The blacksmiths who created this pillar likely had no knowledge of modern chemistry, but through generations of empirical trial and error, they perfected a mixing and forging process that produced a metal of legendary durability. They achieved a level of passive protection that our own science has only recently begun to understand and replicate in laboratories. This was not magic, it was the pinnacle of an ancient industrial art, a secret recipe written not on parchment, but in the enduring metal itself. Such mastery over materials forces us to wonder what other advanced crafts have been lost to time, a question that finds a new dimension when we look at an object that seems to defy the very limits of its medium. Scattered across the battlefields and burial sites of medieval Europe, a specific type of sword carried a name that became legendary. Inscribed with the Stark letters plus ULFBERH plus T, these Viking-era weapons were far more than simple blades. They were the superweapons of their age, forged from a steel so pure and advanced that it should not have existed for another 800 years. While a typical European sword of the 9th or 10th century was a composite of soft iron and high carbon steel, often brittle and prone to shattering in the heat of combat, an Ulfberht was something else entirely. It was made from crucible steel, a material with an exceptionally high carbon content, around 3 times that of its contemporaries. This recipe created a blade that was a paradox, both incredibly strong and remarkably flexible. It would not snap, it could bend and return true, and its edge remained lethally sharp. This was the product of a metallurgical understanding that was centuries ahead of its time. The mystery is not just the quality, but the origin. How did the makers of Ulfberht swords acquire or produce this kind of steel? The smelting process required to create it involves heating iron ore to an extremely high, controlled temperature within a sealed clay vessel, a technique that removes impurities and creates a uniform high-carbon metal. This method was commonplace in the Islamic world and Central Asia, but it was utterly unknown in the forests of Northern Europe. This has led to a compelling theory that the raw material, or perhaps the knowledge itself, traveled thousands of miles along vast trade routes. Viking traders navigating the rivers of Russia could have exchanged northern furs and amber for these ingots of superior steel, known as Damascus steel, from the Middle East. The Ulfberht workshop, wherever it was, may have been a unique hub where this imported material was forged into legendary blades. The story of the Ulfberht is not just one of superior weaponry, but of a fleeting moment of global connection. It represents a peak of technological achievement that was reached, briefly celebrated, and then completely lost. The secret of its steel vanished for centuries, only to be rediscovered with the dawn of the Industrial Revolution. This glimpse of a connected medieval world, where a Scandinavian warrior might wield a blade born from Middle Eastern science, forces us to reconsider the isolation of ancient cultures. It suggests that knowledge and goods traveled much farther and more frequently than we often assume, a theme that is dramatically illustrated by a different kind of artifact altogether, one that charts the very shape of the world. A map drawn in 1513 should not contain such impossible knowledge. In the Topkapi Palace Library in Istanbul rests a fragment of a larger world chart created by the Ottoman admiral and cartographer Piri Reis. He noted in his own writings that he compiled it from 20 different source charts, including one he claimed was used by Christopher Columbus. The accuracy of the map's depiction of the eastern coast of South America is startling for its time, drawn just years after European ships first reached those shores. But it is the bottom of the parchment that ignites the deepest mystery. Below the Atlantic, the map shows a landmass that bears a striking, almost unnerving, resemblance to the northern coastline of Antarctica, a continent buried under miles of ice and not officially sighted by human eyes for another 300 years. Even more incredibly, this southern land is depicted not as a frozen wasteland, but with flowing rivers and topographic features, as if it were mapped from a time when its shores were free of ice, a condition that last existed millions of years ago. Mainstream historians propose a more grounded explanation, suggesting that this controversial land is simply a speculative extension of the South American coast, a common error in early cartography. Yet the geographical fit is compelling. If this is indeed Antarctica, the implications are profound. It suggests that Piri Reis had access to source maps of incredible antiquity, charts drafted by a seafaring civilization with the knowledge and technology to survey a world we thought was still terra incognita. This single piece of vellum becomes a ghost image of a lost atlas, a fleeting glimpse of geographical understanding that was copied, preserved in scattered libraries, and then utterly forgotten. It forces us to reconsider not just who the first explorers were, but the terrifying fragility of human knowledge itself. How many libraries have burned, how many master charts have turned to dust, taking with them the true shape of our world? This question of lost legacy, of a grand design understood in the deep past, finds a powerful echo in a place where the landscape itself was transformed into a perfect celestial clock. Deep within the lush river deltas of Costa Rica, a different kind of geometric perfection lies half buried in the earth. They are the stone spheres, hundreds of them, ranging from the size of a bowling ball to colossal orbs over 6 feet across and weighing several tons. Carved from a hard volcanic rock called gabbro, their sphericity is unnerving. In a world without precision instruments, their surfaces are improbably smooth, their curves nearly flawless. These are not roughly shaped stones, they are objects of pure, intentional geometry crafted over a millennium ago. The immediate question is not just how, but why. Why would a pre-Columbian society invest such immense, painstaking effort into creating so many of these perfect forms? Some archaeologists propose they were territorial markers for powerful chiefs, their size and perfection a clear statement of wealth and authority. Others see a celestial purpose, noting that some spheres were found arranged in alignments that could track the sun or stars, transforming the landscape into a vast astronomical observatory. They might have been physical representations of the sun, the moon, or even the cosmos itself, a way of bringing the order of the heavens down to earth. The method of their creation remains a profound puzzle. How do you achieve such symmetry with stone hammers and abrasives? The most plausible theory suggests the artisans first shaped the rock into a rough cube, then patiently knocked off the corners, and repeated the process through countless generations until a sphere emerged, constantly checking its form with measuring cords or perhaps even by rolling it in a bed of sand to find the high spots. This was an act of supreme patience and a deep, intuitive grasp of solid geometry. The spheres stand as a testament to a human drive that transcends pure utility, a desire to impose perfect, abstract form onto a chaotic natural world. This earthly representation of celestial order finds its ultimate expression in our next artifact, a structure that did not merely track the heavens, but was built to become one with them. Buried in the earth for 3,500 years, a bronze disc no larger than a dinner plate silently rewrites the dawn of European astronomy. Discovered by looters in the German forest of Nebra, this artifact, known as the Nebra Sky Disc, is the oldest known portrait of the cosmos. Its blue-green patina is inlaid with gold leaf symbols that are anything but random decoration. A large circle and a crescent arc represent the sun and moon, while a scattering of stars includes a distinctive, tight cluster of 7, almost certainly the Pleiades. 2 golden arcs frame the horizon on opposite sides, and a final, mysterious arc at the bottom, often called the solar bark, suggests a vessel carrying the sun on its nightly journey. This was not merely a symbolic picture, it was a sophisticated calculating device. By aligning the disk with the actual sky, its users could determine the critical need to insert a leap month, synchronizing the lunar calendar with the solar year. This correction was vital for an agricultural society, ensuring that spring festivals and planting seasons occurred at the correct time. The knowledge required to create such a tool is staggering. It implies generations of meticulous night sky observation, the recognition of complex celestial patterns, and the mathematical insight to bridge 2 different cycles of time. Here, in the heart of Bronze Age Europe, we find not primitive stargazers, but accomplished astronomers who had mastered the abstract language of the heavens and cast it in gold and bronze. This profound connection between earthly life and celestial order, captured on a portable disk, finds its monumental, fixed expression in a structure where an entire landscape was transformed into a perfect clock for the sun. The Nebra Sky Disc gave Bronze Age Europe a fixed map of the heavens, but the Vikings carried their own celestial compass in their hands, across the treacherous gray expanse of the North Atlantic, where the sun could vanish for days behind a solid ceiling of cloud. Norse sagas speak of a magical crystal, the Solarstein. This was no mere myth. When held to the sky, this stone was said to reveal the hidden sun, guiding longships with unerring accuracy from Norway to Greenland and beyond. The secret likely lay in a transparent crystal of Icelandic spar, a form of calcite. This crystal possesses a unique property called birefringence, meaning it splits a beam of light into 2 separate rays. By rotating the stone and looking through it toward the sky, a skilled navigator could find the point where the 2 images aligned in brightness. This alignment directly reveals the polarization pattern of sunlight, which forms a ring around the hidden sun itself. It is a natural GPS using the fundamental physics of light as its signal. While no sunstone has ever been found in a definitive Viking context, practical experiments have proven it works with stunning reliability. This means Viking sailors did not just brave the open ocean by reading waves and watching birds. They commanded an empirical, almost instinctual understanding of optical science. They used a tool that allowed them to see the invisible, to navigate by a sun they could not see, a technological leap so subtle and sophisticated it feels utterly modern. This mastery of the natural world for practical survival stands in quiet contrast to an artifact that served a similar purpose, not for wayfinding across physical seas, but for navigating the sacred landscape of the afterlife. Sometimes the most compelling mysteries are not hidden in the earth, but are carved in plain sight upon temple walls. In the Temple of Seti I at Abydos, a panel of hieroglyphs has ignited a firestorm of speculation. To a modern eye, the overlapping carvings appear to depict a helicopter, a submarine, and even a jet plane, their silhouettes uncannily precise against the ancient stone. This is the so-called Abydos helicopter, a collection of symbols that seems to scream of time travelers or lost civilizations. The mainstream explanation, however, is a fascinating lesson in archaeology itself. Egyptologists identify this as a palimpsest in stone. The original carvings, which spelled out the name and titles of Seti I, were later carefully chiseled out and replaced with the titulary of his son, the great Rameses II. Over millennia, the plaster used to fill the initial carvings has fallen away, and the erosion of the stone has merged the older and newer hieroglyphs. The result is a visual accident, a chance overlapping of symbols that our pattern-seeking brains assemble into familiar, modern forms. We are not looking at blueprints for aircraft, but at a ghostly double exposure of royal propaganda. This phenomenon, known as pareidolia, is the same instinct that lets us see faces in clouds or animals in rock formations. The Abydos helicopter endures not as proof of ancient technology, but as a powerful symbol of how our own world shapes our interpretation of the past. We project our present onto their past, searching for reflections of ourselves in the artifacts they left behind. This tendency to reinterpret through a modern lens forces us to approach the next artifact with a different kind of sight, one that looks past the superficial shape and into the profound mathematical truth encoded within. A simple bone scarred with notches can hold a universe of thought. Discovered near the headwaters of the Nile in the Congo, the Ishango bone is a baboon's fibula, a tool carved roughly 20,000 years ago. At first glance, its rows of carved lines appear to be nothing more than a primitive tally, a hunter counting his kills, but the pattern of these marks tells a far deeper story. The notches are not randomly scratched, they are grouped in distinct columns. One column contains sets of 3 and 6, another has 4 and 8, and another holds the prime numbers between 10 and 20. This is not simple counting, this is a system. The groupings suggest an understanding of doubling, of odd and even, and of mathematical relationships that go far beyond basic arithmetic. It may have been a lunar calendar tracking the 6-month cycle of the moon, or a practice in prime numbers, the fundamental building blocks of mathematics. Either interpretation is staggering. This humble bone predates the established birth of mathematics in Mesopotamia by over 10,000 years. It forces us to reconsider where and when the human mind first began to grasp the abstract language of numbers, not for survival, but for the sake of pure pattern and order. This was not a record of things, but a record of ideas. The Ishango bone whispers that the spark of advanced numerical cognition flickered in the heart of Africa millennia before it was fanned into flame elsewhere. It challenges the very map of intellectual history, suggesting that our journey toward abstract thought began far earlier and in far more diverse places than we ever imagined. This profound evidence of ancient calculation gives way to a different kind of precision, one that required not just an understanding of numbers, but a mastery of the flow of time itself. The silent giants of Easter Island stand with their backs to the sea, gazing inland over a landscape they once walked. The Moai, these towering monoliths carved from compressed volcanic ash, are more than just stone faces. They are the ultimate expression of a society's will, a feat of engineering that turns a simple question of how into a profound mystery of why. How do you move a 70-ton statue, some as tall as a 3-story building, across miles of rugged, hilly terrain? For decades, the prevailing theory involved log rollers and vast armies of people pulling on ropes, a slow, grinding process of brute force. But a more dynamic and compelling idea has emerged from both local oral tradition and modern experimentation. What if the statues walked? Imagine teams of skilled workers using a system of ropes not to drag the moai, but to rock them carefully from side to side. With each coordinated tug, the center of gravity shifts, and the statue appears to sway forward in a slow, deliberate gait. This walking method is not just folklore, it has been tested successfully with full-scale replicas. It reveals a sophisticated, almost intuitive grasp of physics, leveraging the statue's own weight and momentum to achieve movement with a fraction of the expected labor. This was not brute force, it was a carefully choreographed dance of stone and human coordination. The true marvel, however, extends beyond the physics of transport. It lies in the immense organizational capacity of the Rapa Nui people. To carve, transport, and erect nearly 900 of these statues required a complex, stratified society with master architects, skilled sculptors, rope makers, and teams of trained movers, all working in concert for generations. This was a civilization that channeled its entire cultural and spiritual energy into a single, monumental project, transforming their entire island into a sacred landscape. The silent moai are a testament to what human societies can achieve when united by a common, driving purpose, a level of sophisticated planning that finds a clear echo in the deliberate design of an ancient metropolis. While the silent moai demonstrate a society's power to organize for a singular spiritual purpose, an entire city from a much earlier era reveals a different kind of genius, one focused not on monuments to the gods, but on the quiet dignity of daily life. Mohenjo-Daro, a metropolis of the ancient Indus Valley that thrived over 4,000 years ago, feels strangely familiar to a modern eye. Its streets were not winding, organic paths, but were laid out in a meticulous grid pattern, a deliberate act of urban planning that would not become standard practice for thousands of years. This was a city built by design, not by accident. Every brick, from the homes to the city walls, conformed to a standardized ratio, a universal building block that speaks of a powerful, centralized authority capable of enforcing a master plan. But the true marvel of Mohenjo-Daro lies beneath the streets. The city was crisscrossed by a sophisticated, covered drainage system, with clay pipes channeling wastewater away from homes and into main sewers. This was not a luxury, it was a fundamental principle of public health, a clear understanding that cleanliness was vital for a large, densely packed population. At the heart of the city stood the Great Bath, a watertight, meticulously constructed public pool that likely served a ceremonial purpose, further highlighting the cultural importance of water and purification. This urban blueprint represents a systematic knowledge of civil engineering, sanitation, and social organization that feels almost modern. The people of the Indus Valley did not just build a city, they engineered a habitat for tens of thousands, creating a standard of urban living that would not be rivaled for millennia. Such a feat of measurement and standardization required tools, and it is to one of those fundamental tools, a simple yet profound standard of length, that our attention now turns. The silent, planned streets of Mohenjo-Daro reveal a society that understood the power of a standard measurement. This same principle, but on a far grander and more mysterious scale, emerges from the rolling landscapes of ancient Britain. After meticulously surveying hundreds of Neolithic stone circles and burial mounds across Britain and France, an archaeologist named Alexander Thom proposed a stunning idea. He claimed these scattered sites, built by communities separated by vast distances, were all laid out using the same exact unit of measurement. He called it the Megalithic Yard, a length of approximately 2.72 feet. This was not a rough approximation. Thom's calculations suggested these ancient builders used this yard with a precision that rivals modern surveying, a consistency that appears in the diameters of stone circles and the layouts of complex astronomical alignments. If his theory is correct, it implies something profound. These were not isolated groups of farmers haphazardly piling stones. They were participants in a shared intellectual tradition, a network of knowledge that spanned the region. This suggests the existence of a specialized class of architects or surveyors, individuals who carried this standardized unit from one community to the next, enabling the construction of monuments that shared a common geometric language. The idea of a megalithic yard is not without its skeptics, who question the statistical analysis and suggest the patterns could be coincidental. Yet the possibility remains electrifying. It paints a picture of a connected Neolithic world, one where a sophisticated understanding of mathematics and geometry was a common cultural currency, used to build a sacred landscape that spoke in a single, measured voice. This concept of a universal standard governing ancient creation finds a beautiful parallel in an artifact that did not measure space, but something equally profound, the mathematics of sound itself. In the silence of a royal tomb, the ghost of a melody waits. The great death pits of Ur, dating to 2,600 years before the Common Era, held more than gold and jewels. They held the world's oldest surviving orchestral instruments. These are the lyres of Ur, exquisite chordophones with wooden sound boxes, inlaid with lapis lazuli and shell, and adorned with a golden bull's head. They are breathtaking works of art, but they are far more than that. When archaeologists and musicians studied their proportions and the placement of their strings, they made a stunning discovery. These instruments were not designed for random notes. They were built to be tuned to a specific, mathematically precise musical scale. The Sumerians had mastered the harmonic intervals that would one day form the foundation of Western music. They understood that pleasing sound was not a matter of chance, but a law of physics, a predictable relationship between string length and pitch. This was the application of advanced mathematics to create beauty. It means that complex musical theory, the abstract system of scales and modes that we associate with later Greek philosophers, was already a highly developed science in one of humanity's very first civilizations. Music is mathematics made audible, a harmony of ratios that can be felt as well as calculated. The Lyres of Ur are proof that this sophisticated intellectual and artistic pursuit, this desire to codify and create emotion through number, was flourishing over 4 millennia ago. It reveals a culture that sought harmony not just in sound, but with the very order of the universe, a quest for cosmic balance that finds its ultimate expression in a structure that perfectly captures the rhythm of the year. The intricate grid of Mohenjo-Daro reveals a civilization obsessed with order, but another ancient culture achieved a different kind of precision, one that measured not space but time itself. The Maya did not simply track the days, they wove them into a complex tapestry of interlocking cycles, creating a calendar system of breathtaking mathematical sophistication. While medieval Europe was still using the clumsy Julian calendar, which drifted out of sync with the seasons, the Maya had calculated the solar year to be approximately 365.2420 days. Their figure is staggeringly close to the modern calculation of 365.2422 days. This was no guess, it was the product of relentless, generations-long observation of the heavens. Their system was built on multiple synchronized calendars, the 260-day sacred round, used for ritual and divination, meshed with the 365-day solar year to create a 52-year cycle known as the calendar round. But their most famous innovation was the long count, a linear chronology that placed any given day within a grand cycle of over 5,000 years. This allowed them to inscribe their history on stelae with pinpoint accuracy, recording events across vast stretches of time. Their astronomical prowess went even further. They tracked the complex cycles of Venus with remarkable precision, predicting its appearances as both the morning and evening star, and they could forecast solar and lunar eclipses. This required more than just watching the sky. It demanded a deep, abstract understanding of celestial mechanics and the patience to maintain meticulous records for centuries. This knowledge was not merely practical, it was the very bedrock of their existence, a sacred science that connected the rhythm of the cosmos directly to the fate of their kings and the well-being of their world. Their calendars were not just tools, they were a philosophical statement, a declaration that time itself was a divine, measurable force. This profound temporal awareness brings us to our final artifact, an object that seems to defy the very flow of time itself. Our final artifact emerges not from the shadows of antiquity, but from the dry hills of 20th century California. In 1961, 3 rockhounds hunting for geodes cracked open a promising nodule. Inside the hard shell, they did not find the expected crystal cavity. Instead, they uncovered something that seemed utterly impossible, a mechanical object. It appeared to be a ceramic cylinder with a metal core, all encased within the stone, looking unmistakably like a modern spark plug. The geode itself was dated by some to be 500,000 years old, a claim that ignited a firestorm. Here was the ultimate out-of-place artifact, a piece of 20th century technology impossibly embedded in ancient rock. It seemed to be undeniable proof of time travelers, lost advanced civilizations, or a complete flaw in our understanding of geological time. The mystery was as thrilling as it was baffling, yet the truth, once uncovered, is just as compelling as any fantasy. The object was indeed a spark plug, a common champion model from the 1920s. The stone surrounding it was not a half-million-year-old geode, but a concretion, a hard mineral shell that can form with surprising speed around a foreign object, especially in conditions rich in iron and other minerals. A forgotten spark plug lying in the dirt for a few decades can, through natural chemical processes, become completely encased in a rock-like shell that mimics the appearance of a genuine geode. The Coso artifact stands not as proof of ancient technology, but as a powerful lesson in scientific humility. It reminds us that our desire to find the extraordinary can sometimes lead us to misinterpret the ordinary. The true investigation is not just about the object itself, but about our own perception, our eagerness to see what we hope is there. This final story brings our journey through 20 artifacts to a thoughtful close. We have witnessed the undeniable genius of the Antikythera Mechanism and the baffling precision of Puma Punku. We have seen how a Viking Sunstone harnessed the physics of light and how a simple bone from Africa recorded complex mathematics. These objects challenge our timelines and expand our understanding of human ingenuity. Yet, the tale of the Coso spark plug serves as a crucial counterweight, a reminder that our search for lost knowledge must always be paired with rigorous scrutiny. The greatest mystery is not always in the artifact, but in the delicate balance between our wonder at the past and our responsibility to the truth. These scattered flashes of genius across time and space reveal a profound truth about human history. The story of innovation is not a single, unbroken line leading directly to our modern world. It is a tapestry woven with threads that were cut short, a landscape of isolated peaks rising from the plains of time. The intricate gears of the Antikythera mechanism did not lead directly to the pocket watch. The rust-resistant iron of Delhi did not spark an industrial revolution. These were brilliant local phenomena, achievements born from a unique convergence of need, resources, and intellect in a specific place and moment. They represent what human minds are capable of, even without the accumulated knowledge of a global civilization. So why did these sparks often fail to ignite a lasting fire? The reasons are as human as the inventions themselves. A society can collapse under the weight of environmental change or conflict, its libraries burning and its master crafters lost. Knowledge can be so tightly held by a priesthood or a guild that it never spreads beyond a small circle, vanishing when that circle is broken. Sometimes, a technology is simply not adopted by the next generation, an ingenious solution to a problem that no longer exists, or a luxury that a poorer, simpler society cannot afford to maintain. The Viking Sunstone was a miraculous navigational tool, but when the longship era ended, its precise use faded into legend. The lesson is not that our ancestors were less capable than we are, but that the preservation of knowledge is as fragile as it is precious. Our own globally connected, digitally archived world gives us an unprecedented ability to build upon past discoveries, but it also invites a quiet humility. What brilliant innovations of our own era might be forgotten in 1,000 years, rendered obsolete or lost in a digital dark age? These 20 artifacts remind us that progress is not a guarantee. It is a choice, a continuous effort to learn, to share, and to safeguard the light of understanding, no matter how brightly or briefly it may shine. From the geared astronomy of the Antikythera mechanism to the potential spark of the Baghdad Battery, these 20 artifacts form a chorus of whispers from the past, each one challenging the conventional timeline of human achievement. They stand as powerful evidence that our ancestors were not primitive figures stumbling toward the future, but brilliant innovators whose full intellectual legacy we have only partially uncovered. The gears, the maps, the flawless stonework, and the uncanny alloys all point to a deeper truth, that the capacity for advanced thought is a constant in the human story. The most profound mystery, then, may not be how they possessed such knowledge, but why so much of it faded into silence, forcing later generations to painstakingly rediscover principles that had already been understood. This cycle of discovery, loss, and rediscovery should humble us. It suggests that progress is not an inevitable upward climb, but a fragile inheritance that requires active preservation. Let this exploration be a call to keep an open and endlessly curious mind about the past, for it holds secrets and surprises that can still astonish us today. We would love to hear which of these artifacts you find most compelling. Share your thoughts in the comments below and subscribe for more journeys into the world's greatest historical mysteries. The past is not a closed book, but a story still being written with every new fragment unearthed from the earth.